All right, so this note sheet is applications of the law of cosines. Your assignment could be applications of sines, law of sines or law of cosines. So it just depends on what you're given, which law that you use. And so the first thing we're going to decide is which would we use, law of sines or law of cosines. And so we have typed up here when you use which one. So hopefully by the time you take the ACT again, by the time you take the challenge exam, you'll have that memorized. You won't have to look at it. But for A, we have two sides and an angle. So they both have a thing for two sides and an angle. If it is an opposite angle, it should share a label with one of the sides. Right? And this one doesn't. So that would be two sides and their included angle. So that should be law of cosines. Because we have A and C for our sides and angle B for our angle. So, all right. And then B, we have two angles and a side. Two angles and a side is always law of sines. You don't even have to look at the ABC stuff. It's just automatically law of sines. All right, for C, we have two sides and an angle again, but this time the angle matches the label on one of the sides, so it is law of sines. And then anytime we have three sides, we use law of cosines. Okay, so on our examples, we are going to apply one of the laws. So for example 2, a port is 50 miles due north of a lighthouse. A ship is 30 miles at a bearing of north 37 degrees east from the lighthouse. How far is the ship from the port? All right, so the port is north of the lighthouse, so I'm going to put the lighthouse down at the bottom and then port directly north of that. And then the ship is at a bearing of north 37 degrees east from the lighthouse. And so if I connect those, that kind of makes it should make a vertical line. And then from the north, which is where the port is, we're going to rotate 37 degrees toward the east, which is going to be this direction. And we'll say that that is 37 degrees. All right, and then now let's label some sides. And so the distance between the port and the lighthouse is 50 miles. And then this is the ship. And the distance between the lighthouse and the ship is 30 miles. And what we want to find is how far the ship is from the port, which is this distance right there. Okay, so because we have two sides and the angle between, we are going to use the law of cosines. And what we're looking for is, I'm calling x, you can call it whatever you want to, but it's going to be x squared equals, and then 50 squared plus 30 squared minus 2 times 50 times 30 times the cosine of the angle that's across from what we're looking for, which is 37 degrees. Right, and then again, we are just going to leave this as this big long square root. And that should be in miles. Okay. And then example 3. In a softball game, a batter hits the ball to center field. The center fielder then throws the ball to third base, and then the third baseman throws the ball home. The distance from center field to home plate is 240 feet. The ball took a 45-degree angle from the third baseline. The distance between the bases is 60 feet. Draw the triangular path the ball took on the diagram below and decide how far did the center fielder throw the ball. Okay, so let's see. The ball left home plate, which is here, and goes to center field, which is like straight there. And then the center fielder threw the ball to third base, which is here. And then the third baseman throws the ball home. Okay. And it does tell us the ball took a 45-degree angle from the third base line. That's 45 degrees. And traveled 240 feet to the center fielder. And the distance between the bases is 60 feet. And what we want to know is how far did the center fielder throw the ball? That would be that distance right there. Okay, so we're looking for x again. It's going to be equal to our two sides of our triangle that we know squared and added together, and then multiplied by 2 and subtracted. Times the cosine of the angle across from what we're looking for. All right, so this is another two sides and the angle in between. That's why we're using law of cosines. And then really all we need to do is just do that square root. And this distance is in feet. Okay, so what I want you guys to do is finish the application worksheet, where at the beginning you do have to do some like example 1, and then it's just applying law of sines and law of cosines.